of practice problems on that. So I didn't know what to do. I searched for so long.
Sure.
But that's a kind of integration by parts. So.
It is, yeah. It's a way to do them when they get lengthy, because there's a pattern to the answers.
And I think I did pretty, like, I understood that section pretty well. So I think that one is more just like a very like light review. Because I'm pretty sure I understood that one.
Yeah. I'll maybe point out some things here after we do a couple of these to see. So point that out. So this number one is it is an integration by parts. If you're seeing my screen, I assume you are.
Yeah.
It's integration by parts because there's no u that gets rid of the x. So you have to assign a u and a dv. And the u is the thing that you're going to take the derivative of. Usually it's the polynomial, and the dv is the thing you're going to integrate, which in this case is the rest of it. So du is 3 dx, and v, you're integrating both sides here. This becomes minus e to the minus x. The reason there's that minus out in front is because of the derivative of the inside function. There's a negative to go with it.
Yeah.
So then your integration by parts, uv minus integral v du, you get 3x times negative e to the negative x minus the integral of minus e to the minus x times 3 dx. And then you just do a little simplifying here. So this becomes minus 3x e to the minus x. These two negatives go together, so you have plus integral 3e to the minus x dx. And then you take the integral of this, so minus 3e to the minus x plus c. Don't forget that.
Yeah.
And kind of carry that through. So.
Okay.
Let's look at number 3 next.
Okay.
We will come back to 2, but let's talk about 3 because it's kind of the same type as this one.
Sure.
And I'll say this a little pretty early in the lesson. I mean, there's not much here that's interesting. This is not. I mean, these are just doing problems. It's not. There's no nothing you're gonna be revealed here. No revolution. So your u is again the polynomial. Your dv is the other thing that's left over. Du is 2x dx, and v is, you're integrating both sides, sine x, like that. So it's uv minus integral v du, x squared sine x minus integral sine x times 2x dx. So like this thing on the right here, again, it's not, you can't integrate it. So you, with known methods, that's why I have to use this integration by parts. Might be worth rewriting here. Usually the polynomial comes in front.
Yeah.
And then your u is again that polynomial. So ndv is the trig function, sine x dx. So du is 2 dx. V is minus cosine x. And then this is where you just got to be very careful with your intentional with your parentheses. It's uv minus integral v du, but this is all, inside here.
Yeah.
This is where most students, have some issues. X squared sine x minus, or I guess, minus uv, so minus, maybe I'll do it in here, 2x minus cosine x minus integral minus cosine x times 2 dx. Put that there like that. So that's x squared sine x, and then this negative cancels with the one inside there. So that's plus 2x cosine x. This negative goes here, but there's a negative to go there. So it's minus integral 2 cosine x dx. And then antiderivative of this is minus 2 sine x plus c.
Okay.
So this is where we can maybe talk a little bit about that tabular form. You can see that the polynomial goes down.
Yeah.
X squared, 2x, and 2. But there's also sign issues. That has to do with the derivative of sine. Derivative of sine is cosine. Derivative of cosine is minus sine. And I think there's some like alternating signs. The tabular form is really meant for, I don't know, I'll say 3 or more integration by parts,
Okay.
which I'm not seeing.
Yeah.
And based on what you just described to me for your first quiz, like I wouldn't spend any time on it. And
Yeah. I mean, the chances are I also could just get like even only one question on tabular integration. So they're very short and like to the point.
yeah, and there's some resources available for them. Like let me show you. Let me grab this. So like this is a better example of it. Integral x to the 6th e to the x, and the let me snip this in. So you're supposed to make a table like the following here, where you put each of them. Hopefully you've seen this before.
Yeah.
And then you take derivatives on the left, you take derivatives on the right, but you're also supposed to alternate the signs.
Okay.
And so like that isn't necessarily like the best example because like the sign doesn't change, but I mean here's maybe a better one. I mean we kind of did it. So let me do this one. Integral x squared e to the x dx. So your d is x squared, and then your I is e to the x. Okay, and then you have this sign. Like some people put the sign here, and some put the sign here. I don't know what you.
I put it like right in between them.
Okay, so the sign here. So it goes plus, minus. So this is 2x. This is e to the x. This is 2, and then this is 0, plus, minus, and then like this. And then
Plus, right?
I'm sorry.
It always starts with plus. Right?
Yes. Although, let me go look. Something, oh, that was because of the derivative. Okay. Yeah. So then you always, they show these arrows. And so that helps you to write out your final answer.
Okay.
So it would be like x squared e to the x minus 2x e to the x.
2x.
Yeah, what am I missing here? 1, 2. Yeah, plus 2 e to the x plus c. I found this to be really confusing. Maybe you don't, maybe you find this okay. I didn't really care for this, but I never do this by hand. So
it just seems like unnecessary busy work. But
it really is. But in college, like I've seen exams where these are common questions you get asked.
Okay, just good to know.
Okay. So the next problem type we should look at is 2.
Okay.
So this is one of those where you might even want to rewrite it like this, because this is I think this is the more common form where it's x to like cubed natural log x, but
Yeah.
This time your u is not the polynomial, it's the ln, because you know the derivative of ln, but you don't know the integral of ln. But you do know the dv. You do know how to find the antiderivative of a polynomial or rational. I'm sorry, rational in this case.
Mhm.
So your du is 1 over x dx, and your v is minus 1 over x. And uv minus integral v du. Okay, so when you integrate here, you get natural log of x minus 1 over x minus integral minus 1 over x times 1 over x dx. So that's negative natural log of x over x plus integral 1 over x squared dx, which we actually already found. I can't remember if that always happens with these ln's, but does seem to be a common thing here. So that's minus 1 over x antiderivative plus c.
Okay, yeah.
Let me see here. So I think to me, the more common one is something like this: x to the fourth natural log of x dx. And this is pretty quick. It's x to the fourth for that. I'm sorry, that's wrong. Your u is the natural log of x because you can take the derivative of that.
Yeah.
Your dv is the one you can actually integrate. Some instructors are really picky on notation here. So your uv minus integral v du, like that. 1/5 x to the fifth natural log of x minus integral 1/5 x to the fifth times 1 over x dx. So not quite the one on the right here. It's integral 1/5 x to the fourth, but it's basically the same thing. So you get minus 1 over 25 x to the fifth plus c, and then you can bring this down.
How'd you get the? Oh, never mind. Figured it out.
Screen just froze for a minute. So I consider problems where we started today, like this is type 1. This is also type 1. It's a polynomial times a cosine or a sine or an e.
Yeah.
And then kind of that's the same thing. This is the other type, which is a polynomial times ln. Those are fairly common. And then the third type is where you have to do integration by parts twice, and you get back to the original. And that's like what one of these types would be. So for example, you have a choice here of making your u and your dv actually either, but you want to be consistent. So you have to choose, like, what do you prefer to integrate and what do you prefer to differentiate? I guess I would prefer to take the derivative of e.
Okay.
And the preference is because that coefficient comes out in front each time. Whereas if you have to take an antiderivative of that, you're going to get fractions.
Yeah.
It's a small preference. It's like, home jersey versus away jersey. I don't know. I mean, maybe it doesn't really matter ultimately. But you got to be able to do these pretty quickly here. Antiderivative sine is cosine minus cosine x. So if you know ahead of time, it's good to rewrite this. It's good to rewrite it on the left-hand side and put everything on the right-hand side. But sometimes you don't remember and you got to do it a couple times and you're like, oh yeah, that's the same. So our u is e to the 2x minus cosine x minus integral minus cosine x 2e to the 2x dx. So your minus e to the 2x cosine x plus integral 2 cosine x e to the 2x dx. Now, I think this is a very important kind of reminder tip is you really want to use the same substitutions, meaning like if you made u the e and your dv the trig function, you should carry those through here.
To the next one, yeah.
Yeah, I actually don't remember if it works or doesn't work if you mix it up, but you know, why take a chance? And again, like you got your choice here. I'm gonna put the 2 with the e. That's kind of another little wrinkle. Try to keep the antiderivative one as clean as possible.
Yeah.
4e to the 2x dx, and v is sine x minus e to the 2x cosine x, uv, which is 2e to the 2x sine x minus integral 4e to the 2x sine x dx, and lo and behold, you get this thing on the left here. This and this are multiples of each other. Okay. And that's what you're supposed to get. It doesn't always have to be minus, depending on the signs of exponents and things like that. Yeah, so, but the next step is to move it over. So that's 5 integral, because I'll bring the 4 out, 5e to the 2x sine x dx equals minus e to the 2x cosine x plus 2e to the 2x sine x, and then a divide by 5. Then you got a c too also. At some point you got to throw that in, but you can wait till the last line.
Okay.
If I had to guess, you would get a problem like this, because this is kind of the like why you would do an integration by parts, because it is the only way. It's the only way to do this problem. There's no other way. Problem like this. So some sort of e times sine or cosine.
Okay.
So that's like the 3. I call those like the 3 types you would see for this, but there's obviously other problems here, so we can unpack them. The other sort of classic problem that I don't see on, I kind of see it, but it's this one. Is this, and this is an integration by parts problem.
Okay.
And the reason this one is and it's given on tests is because it's a bit deceptive, because you make this your natural log of x, but well, what is dv? If you remember that dv is everything else, which in this case is just dx,
yeah,
then you can do it.
Oh, okay.
But if you don't, I'm not sure. It's could be tough here. So du is 1 over x dx, v is x, so you get x natural log of x minus integral x times 1 over x dx, which gives you x natural log of x minus integral dx, x natural log of x minus x plus c.
Okay. Easy. Just got to remember that first step.
Yes.
Gotcha.
So 5 is very similar to that. We can do that one next. So again, the u has to be something that you can take the derivative of, and you can't take a derivative of dx. So your du must be cosine inverse x. And thank goodness, because this is one you can actually figure out. It's 1 over square root. I'm not sure. I think it's square root 1 minus x squared.
Yeah.
Gotta look. Arc cosine. There it is. Negatives. Negative square root 1 minus x squared. My
1 minus x squared.
yeah. My old calculus teacher would be very angry with me. All right, and then dv is dx. Great. So v is x. So when you find when you do your uv minus integral v du, you get x cosine inverse x minus integral x times minus 1 over square root 1 minus x squared dx. And so this goes up here. So it's x cosine inverse x plus integral x over square root 1 minus x squared dx. And sometimes when you're doing these integration by parts problems, when you're doing them, a lot of them in a row, you like try to use integration by parts in something that isn't.
Yeah.
And I kind of liken it to like back when you did factoring, like if you did quadratic formula like over and over again, and then like you got one that could just be factored really quickly, but you didn't see that, you're like, why did I do that? Well, this is what this is, because this is a u substitution.
Okay.
And your u sub here is u is 1 minus x squared, because your derivative is in the function. It's up here. X over square root of u dx is du over minus 2x. See, the x's cancel, so you get minus 1/2 u to the minus 1/2 integral du, and all said and done. And then your antiderivative is u to the 1/2 over 1/2, but it's going to cancel with that 1/2, so it becomes negative. And I've already lost what my u was. It was 1 minus x squared. So this is minus square root 1 minus x squared. And then I got to bring this down here, x cosine inverse plus c.
Okay. It wouldn't be. Oh no, never mind. So I was about to say it's not going to be to the 1/2, but then I realized the square root is the same thing. Took me a second.
It's a good place to just take a 30-second break here.
Yeah.
Okay. So I've avoided doing 4.
Okay.
But I mean, we should do it at some point. Did you get exact copies of what was on the review? On the test, like was it exactly the same, or were they just close enough?
They were close enough. So the 2 questions, I only got the 2 questions that I had for indefinite integrals, and it was just shoot, what's the S thing called again?
The S thing.
First thing.
Integral. Oh, the integral.
Integral. So
Yeah, integrand. Yes.
e to the x over 4 plus 25 over x dx.
Okay.
So that was one of them. And the other one was integral of negative x over 1 plus x squared, 1 plus x squared, minus 12x to the negative 3 dx. So they were similar to what we did. They weren't the same, but like.
Yeah, they were the same sort of category.
Took concepts and like combined them kind of.
Yeah. Actually, I really like this problem. It is integration by parts. Your du is x, which may or may not be obvious. And then your dv is this one on the right. The one on the right here is kind of a tough integral if you haven't seen it for a while, but du is dx. So how to integrate this thing over here on the right? Well, when you integrate, go ahead. Do you have an idea?
The du twice.
Oh yeah.
Sorry.
Yes.
Du again. Okay.
Yeah, u is what it is. All right, so the du dx, that's good. On the right here, it's actually, I take that back. I wonder. So I was gonna let u equal sine x, because du equals cosine x dx. Yeah, that does do it. Okay, so then this over here is not integration by parts. This is u substitution within integration by parts. So this becomes the integral of u du, which is 1/2 u squared, which is 1/2 sine squared x.
Okay.
So you can't do this directly. You try u substitution, your du is already in there. And then it just becomes integral u, power rule, plug it back in.
Okay.
So this is your v down here. uv minus integral v du. So it's u is x, so it's 1/2 x sine squared x minus integral 1/2 sine squared x dx. Boy, that didn't get any better. But this one you can do. Like I say that didn't get any better, but it's totally doable. It's just you have to know one of your trig identities for that.
Okay.
Which I don't know how you would know.
Yeah.
Like it just all of a sudden. But I will provide it here. So the one we're using, boy, this had a lot in it. Cosine 2x equals 1 minus 2 sine squared x.
Okay.
So when you solve this for sine squared x, you get 1 minus cosine 2x divided by 2, and that's what goes in here, which allows you to yeah, so it becomes minus, and then this 1/2 goes with this 1/2, so it's 1/4 integral 1 minus cosine 2x dx, which becomes minus 1/4 x. Antiderivative cosine is sine. 2 negatives make a plus 1/2 sine 2x, because the derivative of that has to come out in front.
Okay.
I'm looking at another, I put this into a well-known thing. It gave me a slightly different answer without the sine squareds. There may be another way to do this that I'm not seeing.
Yeah. Let me see. Let me see if the website that I took it from has anything.
There's nothing wrong with this answer. It's just that you can put them in different forms when it's trig functions and trig powers. You can always use reduction of order on them.
Oh, yeah. So for the website I took it from, they used that sine 2x over 2 equals sine x cosine x.
Oh yeah.
So they use that.
Oh yeah, that's way easier.
I didn't even know that was a thing, so.
I'd forgotten about that. So what they're saying is you can make this, they do this in trig classes, and they can make it like this. It's x over 2 2 sine x cosine x, because 2 divided by 2 cancels out, but now this part right here is what you just said, it's sine of 2x.
Yeah.
And then it's an integration by parts like we did in the first couple problems.
Okay. Okay. They just changed it.
Yeah. We should look at 9 because it's got kind of another oddity in it. I actually don't think 9 is integration by parts. Okay, so I'm just going to show this. This is a u substitution. U is x minus 1. Du is dx. And so when you substitute in, you're going to say, well, Matthew, that didn't work. I'm like, you're right, because there's still an x squared, but you can actually solve for x squared in this line. You can actually say x is u minus 1, sorry, plus 1, and then x squared is u plus 1 squared. So this becomes integral u plus 1 squared, square root of u du.
Okay.
Now, is this the right way to do it? I actually have no idea. And integrals, you can actually do a variety of different ways. You probably can do a integration by parts where this is u and dv is square root x minus 1.
Okay.
Because du is 2x dx, and v is x minus 1 to the 3/2 power times 2/3.
Yep.
I think this is harder, but I don't know. I mean, like this one you would FOIL and then you multiply it by u to the 1/2, so it becomes power rule.
Yeah.
And actually there's a few online systems where they actually won't accept one or the other. Like they want you to do it one way, but they're the same. So I don't know. I mean, these are like your more advanced calculus 2 questions that, I mean, I don't think you need to do. I don't think you need to spend any more time thinking about this.
Okay.
But that I wanted to just comment on that.
Okay. We use.
Yeah, and 7's really similar. Although 7 could fall under trig substitution. It's the form where you've got a number minus x squared.
Okay.
Let me grab that one next. It seems out of place here, but what do I know? So like what you could do is make this integral x squared x square root 9 minus x squared. These are times. And then this is your u and this is your dv.
Okay.
Which is probably how they did it. Because if this is truly integration by parts. And by the way, where did you get this from? These are really awkward problems.
I got it from, it's a PDF from the math program at Berkeley.
Okay, well, that makes sense. So they're very intense there.
Yeah.
Yeah, Unabomber actually went there, I think. That's a terrible aside, but yeah, they're math crazy there.
Yeah.
So yeah, these are way too hard for what you're trying to do.
Okay.
Just so you know.
Yeah, and I think it is that way. The x squared is u, because in both of those problems they have like hints for how they got the solution.
Oh, okay.
U equal x squared.
I see. You're trying to test me to see if I would know to do that.
But I probably will not get one of these questions.
Yeah, I mean, I've been helping students a long time, and I mean, I can sort of tell you when you're going off the wrong direction for these. So, what should we do? We got a little bit of time left. I mean, what other? Do you want me to give you some problems? Do you want me to?
Could we just do like the weirdest tabular integration I could get? I don't know if you have like a tabular integration.
Well, I feel like we've already kind of had it, but it would be some it's some polynomial of x. It's like x to the 5th. And then to make it harder, you would choose something whose derivative changes in sign.
Okay.
So that when you have that plus minus thing, that you actually have to deal with that. So do you want to try this one?
Yeah. Can we try this one?
Sure. So d x to the 5th, I sine x, and then plus. So 5x to the 4th, cosine x, 20x cubed. And see, I'm going to wait on this. It is a plus, but the derivative of cosine is minus sine. So I don't know how you want to do this. Like it, yeah, it becomes this.
Okay.
But then somewhere you got to remember, like it's plus minus plus, and then this is minus.
Okay.
So that's where it can get weird. Derivative of sine is cosine. Plus minus plus, there's a minus there. 120x, derivative of cosine is minus sine. So minus sine x, 120. I keep putting a plus minus plus minus plus minus. I think I got that right. And then 0, and then derivative of cosine is minus sine, but I don't know why I can't remember all these signs. So I guess if I would put the sign over here, but anyway, no, we're doing this wrong. We need to keep these. Sorry.
Okay.
That's how I would do it. And then derivative of sine is cosine, derivative of cosine is minus sine. Derivative of minus sine is minus cosine. Derivative minus cosine. Derivative of cosine is minus sine. Minus cosine. Then the negatives never come out. Maybe you do combine them here. Because derivative minus cosine is
Sine.
Is it sine?
I think.
Yes. Okay. Yes, there it is. It is sine. And then you get cosine is fine. And then this is minus.
Okay.
I think that's right.
Derivative of negative sine is negative cosine.
Yes.
Okay.
So then you pair things up. You go x to the 5th, cosine x, and then this minus 5x to the 4th, but times minus sine x. So I would probably change that. So then plus 20x cubed, but there's a negative there. So that becomes negative cosine x minus 120, no, minus 60. Lose track of these signs.
Good question. When you go from like x to the 5th cosine x, what do you take the positive? Do you take the plus or minus?
I'm sorry. Which give me, ask me one more time.
So it's x to the 5th cosine x, and then when you're moving on to 5x to the 4th negative sine x, do you the plus, which was in line with the x to the 5th, or the minus, which was in line with the 5x to the 4th?
Yeah, that's why I put I like the signs here, because it's plus x to the 5th cosine x minus 5x to the 4th times minus sine x, because I feel like they fit better here. And then you're not messing around with them with your, so then it's plus 20x cubed, but there's a minus cosine x minus 60x squared times sine x plus 120x cosine x minus 120, but that'll make it a plus 120 sine x. So it is not true that these alternate in sign as they do in some sort of some things, but
Okay. And you just put that all together and add C.
yeah, plus C.
Okay. Okay. honestly, I kind of think that's it. I don't know what else.
Well, there's a lot here. Like if you were to just spend a little more time tonight reviewing, just a few of the problems, especially the early ones, those that will probably benefit you, 80%
Yeah, for sure.
chance you get something just like it. All right. Well, I know we got a lesson tomorrow, so I will see you then. I'll send you the notes here shortly and hope you have a great rest of your night.
You too. Thank you.
You're welcome. Bye now.